Okay, so our lesson on 1.6 part 2 from Pearson is going to have us solve absolute value inequalities. So today we're going to solve the inequalities, give an inequality solution, graph the inequality, and then also give the interval notation answer. So write a couple of notes at the top of your page, find some room. The first note is the same one as yesterday. We are going to set up two problems. So just like with the absolute value equations, every problem that we do is actually two problems in one. Another note I want you to write down, not going to make a lot of sense yet, just hang with me, is the second problem. We have to flip and negate. Fancy word that means to make the solution negative. We'll talk about what that looks like in a second. And then the other thing I need you to write down is something that's from last week, and versus an or. So if I was going to graph a typical and problem, remember and was the intersection of two inequality graphs. So typically ands looked like this, where you had a point and you shaded in between them. And typically an or problem, we were like oars on a boat, remember? Point, shade out, point, shade out. We have seen some special cases of ors where they overlapped, and there's another special case out there for an and problem that we'll discuss in the future. But this is a typical graph for an and versus an or. The other thing I need you to write down today, if you have a less than problem, it's an and. If you have a greater than problem, it is an or. And the best way that we've come up with to memorize that is if you look at less than in front of the word and, if you use your imagination, it kind of sort of looks like the word land. Kind of. The other way is greater than and or, both have R's in them, so they go together. Somehow you have to figure out how to associate less than with and greater than with or. All right, let's see this in action. So the first problem is already set up for you. This guy right here is the original problem. So it says the absolute value of 2x plus 7 is less than 11. I went ahead and took the liberty of setting up your two problems for you. So 2x plus 7 is less than 11, and then I wrote the word and in the middle. 2x plus 7 is greater than negative 11. So first question I have for you is, why is it and? Yes. Because it has to do with this symbol. It has to do with greater than versus less than. So this one is a less than, so that means it is an and problem. Now, this original problem, or this first problem, looks just like the original, except I took the bars off. So I didn't change anything other than removing the absolute value bars. But what is different here in the second problem? We negated the 11, and we flipped the inequality sign. So that's what that note on the other page meant. For our second problem, we flip the sign, and we negate the answer. And now we do exactly what we did yesterday. We solve. And you're going to see the same math happening on both problems, but providing two very different solutions. So I'm going to subtract 7. So 2x is less than 4. And then keep solving. We're going to divide by 2. Yes, sir? Yes. So x is less than 2. I need you to write the word and down as part of your solution. So we're going to have x is less than 2 and then something else that I'm about to find. Same math. Subtract 7. Subtract 7. So we have 2x is greater than negative 18. Then divide by 2, divide by 2. Do I flip here? A lot of kids think I do. Some kids are under the impression that I just flip every single time I divide. But that's not the rule. What's the rule? When do you flip your inequality sign? Divide by a negative coefficient or multiply by a negative coefficient. So my inequality solution is x is less than 2 and x is greater than negative 9. So when I go to write this on a number line, I'm very well aware that you guys can count just fine. So you don't have to like count exactly 11 spaces between them. As long as you put your numbers in the right order, that's all I really care about. So where would which number would come first on the number line? Which furthest to the left? Negative 9, good. And then some other numbers happen, and then 2 would be over here somewhere. Oops. Now I'm supposed to graph all my solutions that are less than 2, so like this way, and numbers that are greater than negative 9. And it's the intersection of those two shadings. So where am I graphing? Where am I shading? In between them. Which, if I think back to what my teacher told me about these guys, ands typically shade in between them. So parentheses, brackets, what's going on? Parentheses. And why parentheses? Yep, the original problem does not have any equality, so the endpoints are not part of the solution. Ands are my favorite, because when it comes to write the interval, I just kind of pick it up off the number line and write it as an interval. So starting at the left, -9 to 2. All right. So very, very similar to our lesson when we learned about and or last week, except this time the problems didn't start out as an and or an or. You got to separate them and create the and or yourself. All right, this next question. The original problem, if it's a less than sign, it's and. So this next problem, absolute value of 3x minus 2 is greater than or equal to 8. So answering your question, is this an and or an or? An or, because it has a greater than symbol, so it's an or. So when I go to set up the first problem, which I already did for you, it just, you take the bars off. And then the word or must show up in the middle here. My second problem varies two ways. I flipped the inequality to a less than, and I negated the solution to a -8. All right, let's solve. We're going to add 2. And you will get a fraction or a decimal here. Because you're graphing, I can understand if you would rather have a decimal. I'm not afraid of fractions, though. 10/3 is good. So x is greater than or equal to 10/3. Make sure that word or comes down in the middle. Same math, add 2, add 2. So now I have 3x is, remember we already flipped this sign for the original problem, less than or equal to -6. Divide by 3, divide by 3. So I get x is less than or equal to -2. So the only thing you can do wrong at this point, well, not the only thing, but the most commonly occurring mistake here, believe it or not, kids who are writing the numbers on the number line in the wrong order. Very important that they go in the right order. Which one comes first on the number line, -2 or 10/3? -2. And again, I'm sure you can count just great. 10/3 is over here somewhere. If you would rather call it like 3.33, that's fine. Whoops. Oh boy. Technical difficulties. There we go. Now let's talk about our graph. I'm supposed to graph all my solutions that are either greater than 10/3, so like this way, or anything less than -2, that way. So this is an or problem. They're kicking out, which is what they're supposed to do. What about on the endpoints themselves? Brackets this time. Why? They're equal to. The original problem has an equal to symbol. Very good. And now for the fun part. Who can tell me what number lives way down here on the number line? -infinity. And who lives way over here on the number line? +infinity. So let's talk about an interval starting from the left. My interval begins at -infinity. And then I keep coloring green until -2. What comes next? There's going to be something here. It's the union symbol. Very good. And then it picks up again at 10/3 or 3.3 and then continues on to infinity. Now, I think probably the interval is the most difficult part at this point in our lives. Literally all you're doing is you're taking whatever I just colored in green and you're like picking it up off the number line and you're writing it in a much shorter notation, which is an interval. The union symbol has to be there because you're telling your reader that both of these sections are solutions. But the union symbol combines them together into one solution. And for Pete's sake, do not put a tail on your U. If you have a weird uppercase U, like from the alphabet U, that does not mean union. And I'm going to be really picky about that, so please don't do that. All right, we are going to, let's see here. I'm going to skip a little bit if you don't mind. Can you flip to the next page and find example C? All right, I did not set up anything for you here. So we have to, right off the bat, ask ourselves, is this an and or is this an or? All right, I'm hearing and. Justify. Why is it an and? Yep, the original problem has a less than, which means we have an and. So when I go to set up my two problems, the first one is just the original with the bars removed. Make sure the word and shows up in the middle. My next problem is almost identical, 4x minus 9. But remember, you got to flip the inequality to a greater than or equal to, and then negate your answer, so negative 21. All right, let's solve. And I've found more and more kids who, like this plus 9 step, they go over here and they do plus 9 over here as well. Like they're on a roll. They just keep going across. We call that simultaneous solving. It's totally fine if that's the way you want to do it. Because if you're going to add 9 to the first inequality, it's going to happen on the second one as well. I will tell you, kids who make really small arithmetic errors, when they simultaneously solve, you're probably not as accurate as you would be if you just slowed down a little bit. So decide if that's you. So here, that's what, a negative 12? And then you're going to divide by 4. So I'm running out of room, so I'm going to write it down here a little bit. This becomes x is less than or equal to 30 over 4 reduces to 15 halves. 7.5 is another way to say that. But make sure the word and shows up. And then x is greater than or equal to, that's what, negative 3? So here is your inequality. In my head, I'm trying to think self, what does an and look like? That's where we're supposed to have endpoint, color in between them. Let's see if that worked out. Which one of these numbers would come first on the number line? The negative 3, good. So this must be your 15 halves. All right, we're going to graph all solutions that are less than 15 halves and things that are greater than negative 3. So are we going to end up shading in between them like we're supposed to? Yeah. How about the endpoints? Parentheses, brackets? Brackets. So interval, pick it up off the number line, starting at the left. Where does it start? Negative 3. And then I keep coloring until 15 halves. If you called it 7.5, that's totally fine. All right. D is the last example we're going to do today. And I think you'll see why we're definitely going to do this one. Has anyone already looked ahead and realized why I want to talk about example D? Yep. You're not going to spoiler alert this for me at all? Okay. Is it an and or an or? It's an or, because this original symbol is a greater than, which means I'm looking at an or problem. So my first problem I have to solve is negative x plus 5 is greater than 6. So just took the bars off. Or negative x plus 5 is less than negative 6. All right, subtract 5. I'm going to simultaneously solve them just so I don't just keep switching colors. All right, be careful here. You still have a negative x is greater than 1, or a negative x is less than negative 11. Still have a coefficient on the x, so we have to divide by the negative 1. Anyone having any thoughts about this one? What happens in inequality when you're trying to solve and you divide by a negative coefficient? Your sign flips, and that happens at that very moment, which is right now. So this becomes x is now less than negative 1, or x is greater than 11. And good thing you remember to flip your signs, otherwise this number line wouldn't make any sort of sense. Which endpoint comes first? Negative 1. There's negative 1. There's 11. And I'm graphing everything less than negative 1, so that'd be this way, or anything greater than 11, that'd be that way. And this was an or problem, so sort of like oars on a boat, kicking out. And parentheses. All right, feeling good. Inequality time, starting at the left. Remember who lives over here is negative infinity, and who lives over here is positive infinity? So think about starting your interval right here and ending it right there. What does that look like? Negative infinity to negative 1. And then how do we jump? Union. Where does it pick up again? 11 to infinity. Very nice. All right, there are more examples. We'll probably work on some of those tomorrow.